Hello class, welcome to the tutorial for how to do problem set 4 in Excel. And I did a couple things differently I used some examples here where I changed the numbers in the original problem and you just need to follow along with the examples. I also made some templates for you so you don't have to get caught up in formulas on 3 of the problems. And the templates have these turquoise colored cells which you'll have right here, in which you just need to plug in your numbers in the turquoise cells for questions 1, 3, and 4. So you just plug in your numbers here, and it will do the rest and give you the information needed to answer the questions about our hypotheses being tested. So, with that said, for question 1, this is about hypothesis testing of two populations. So you'll need to state your null and alternative hypotheses, and you'll need to know this is a z-test for the differences in two means, and I give that to you here. So what you need to do is just plug in the numbers here for the hypothesized difference, the level of significance, which is given in the problem. You need to know the population standard deviation, and the problem is giving you the variance, so you should know that the standard deviation is the square root of the variance. So whatever number you plug in here, I let it calculate the standard deviation for you here, and it writes it into the turquoise area here. So all you need to do really is plug in the numbers for these two, the sample sizes, which are given in the problem, the sample mean, which are given in the problem, the variance, which is given in the problem, and then it'll compute the rest for you. Now with the z-test, you can do the comparisons of the z-test statistics with the critical value and conclude, okay, yeah, to reject a null. But really what you want to pay attention to is the p-value here. In this case, we have, remember this e tells you that there's mega decimal points in this example 52. Excel only lets you go up to 30. So even with that 30 decimal points, you'll see there's a whole bunch of zeros after the decimal point. We know that this number is less than 0.05, so we can conclude to reject the null hypothesis that there's evidence that the dual degree students are receiving lower grades than the regular management students. For question 2, okay, so this is using the data analysis tool pack in the data ribbon. So you go to data analysis, F-test for two sample variances, and you click OK, and select the range for method 1, select the range for method 2, and make sure you check the label boxes if you have them in there, and where you want to put the results. So I'm going to put the results down here on the same sheet and click OK. So what you want to pay attention to here, again, is the p-values, okay? So I'm going to move back over here. This is a one-tail test, and this question, though, is the hypothesis really is being tested that they're just different, okay? I'm sorry, the same. So the hypothesized difference is 0. So it's not asking for any direction. However, this test is a one-tail test, so you have to take this p-value, this one-tail p-value, and multiply it by 2, okay? Okay, and ask the question, is this less than 0.05? We know that it is not, so you can accept the null. There is no significant difference between the two methods. So be aware of the multiplication here on the p-value. For question 3, hypothesis testing the p-value. Okay, so this is a t-test, hypothesis of the mean. Again, so all you really need to be concerned here with this IQ, this set of array of numbers, is, and it's asking, is it different from 100? Okay, so our null hypothesis, is it different from 100? Our p-value, which is 0.05, is given in the problem. So all we're doing is taking information from the problem, plugging in, and that is that. Okay, we can see two things here. Again, that this is greater than this, but again, our p-value, look at it, it's 0.02. Is that less than 0.05? Yes. Okay, so you reject a null. Question 4. Okay, so this is hypothesis testing on a proportion. Again, you take the information from the problem. In this example, I have 60%, so I just put in 0.6 here. Our significance level is 0.05, so we just plug it in there. Our number of items of interest is our sample size. In this particular example, I have 37. I just plug it in there. And then our overall sample size was 100, so I just plugged it in there. It calculates the proportion, and then the z-test statistic compares the z-test statistic against the upper critical value of 1.64. It also calculates the p-value. Again, you can compare these two. Okay, so we're not rejecting the null. However, this p-value, once again, is greater than 0.05. So again, that further supports that you're not rejecting the null. Okay, and make sure you put this in the context of the problem about the UMUC proportion of students that change their major. Okay, just don't say reject or accept a null. Make sure you do that for the other problems as well. Context is important. You're testing a hypothesis within a context. Okay, question 5, the 3 scatter plots. I don't know why these problems are in here, but they are. And this first example, problem A, doesn't even make sense. Why these two would be correlated and why you would want to make a scatter plot. But this is the problem, and I'm going to show you how to do it. It's really easy. Okay, you just select the 2 columns of data. Okay, you go to insert and you see the little scatter button up here. Click that, click the first one, and boom, you've got your scatter plot. Now, a few things you want to do here. You want to go to the layout tab here, get rid of the legend, so that's going to get rid of that. You'll want to add an axis title to each one. So in this case, you would put in dollars or gross movie sales or whatever. Do the same for the vertical column. Now, another thing though, which is kind of helpful for scatter plots, because a scatter plot is a graphical representation of a correlation. In this particular example, I don't know why these would be correlated, but the problem thinks it is. But if you had a real life problem and you think there's a correlation, what you want to do is right click on the graph and add a trend line. Okay, and you're going to get this little menu here. You're going to just click the box for display equation on the chart and display the r-squared value on the chart. And what this is going to do, it actually calculates the correlation for you, which is kind of cool. And if this was actually a linear regression where you actually specified an x and a y, an independent and a dependent variable, this is actually bypasses you having to run the regression as well. So just click close and you'll see our little trend line here, and you see our equation. You can move it right out of the way. This r-squared is our correlation, which is 0.0042, which means there's absolutely no correlation here whatsoever. Now, the thing with scatter plots, you want to know you'll have to know what different types of relationships look like: positive versus negative, and then strength. Okay, and that's that 0 to 1 correlation relationship. The cluster of the dots will look differently depending on the strength and direction of the relationship. But this one, the numbers, the dots are all kind of clustered in the middle, and you have several outliers here, so there's no correlation here whatsoever, and that 0.0042 is evidence to that. So make your graph look pretty: title, axis labels, trend line, and make sure you add the equation, and you will be a scatter plot graphing professional. And just repeat that for the 2 other problems. And that is it. Any questions? Just ask.